Everyone, welcome to practice report number 19. In this case, we are having the presence detection with pyroelectric sensor and an actuator bulb. So we are using a sensor that has an output, analogic output. We are using the FPGA University program. We are using the buffer 245 to have to minimize any kind of noise we can have on the relay model. Here's our relay model. It's just a simple connection of normally open and common. Those are connections for the bulb. And what else? I think that's about it. We have one input, that is the sensor, and one output, that is the bulb. So the output is connected right into the buffer, and the output of that buffer is connected to the relay module. So anytime the sensor detects any kind of movement, it's gonna send data to the FPGA, and the FPGA is gonna get that data and send a 1 to the output. In this case, it will be right into the bulb. So anytime the sensor detects movement, the bulb is going to turn on. So I'm gonna give you guys an example. As you can see, now it's detecting myself, so the bulb is gonna turn on like that. And there you go. So these sensors are really common on houses, so that any person that gets in close proximity is going to be light out. So that's everything for today. Thank you so much for watching this video.
Hello, welcome back to the practice number 19. It's about presence detection with a pyroelectric sensor and an actuator spotlight. So this is Quartus Prime. We are programming an FPGA for Max 10 from Intel. So as you can see, we're using the ADC code because the model of the sensor is analog. So here we have the ports. As you can see, we have the clock and reset as STD logic. The segment 0 is an output, and it goes from STD logic vector 6 down to 0. And seg 1 is also an output, STD logic vector 6 down to 0. Seg 2 is also an output, STD logic vector 6 down to 0. And seg3 is also an output, STD logic vector 6 down to 3. And finally, we have the S, and also is an output, STD logic vector, but this in this case is 3 down to 0. And then we have the output for the LED output. So basically, when we connect this in the physical part, you will see that we have a LED connected, and in this case that will be the spotlight. So now I'm gonna jump for the last part because everything of this code I have already explained it in other videos, and this is a part of the code that we are using. So if BCD is equal or bigger than 1500, then the LED will turn on. It will turn off, I mean. This is the spotlight. Else, it will turn on. So, this is all for this video.